Hey everyone, welcome back to Aeroter Academy, your ultimate hub for everything about aerial and underwater drones. Today we are diving into the building blocks of any drone, its basic components. Whether you are a beginner, a drone enthusiast, or planning to build your own drone, this video will break down what makes a drone. So let's get started. At its core, a drone is a flying robot that can be controlled remotely or fly autonomously. But to achieve flight and perform its tasks, every drone relies on few essential components. Let's take a closer look at each one. First one is the frame. Think of it as the skeleton of the drone. It provides the structure and houses all the components. Frame comes in various shapes. Example: X frame, H frame, or even custom designs, depending on the drone's purpose. Materials like carbon fiber are light, yet strong, making them ideal for aerial drones. Next, we have the motors and propellers. These are the muscles of the drone, generating the thrust needed for liftoff and maneuvering. Most of the drones uses brushless motors for their efficiency and durability. The propellers are carefully designed to push the air down, creating lift. The direction in which the propeller spins, clock and anti-clockwise, is crucial for stability and control. The brain of any drone is the flight controller. It processes data from various sensors and translates your inputs into actions, like adjusting the motor speed to keep the drone stable and balanced. Modern flight controllers often comes with advanced features like GPS navigation, altitude hold, making them smarter and easier to control. Electronic speed controller, or ESC, acts as intermediary between flight controller and the motors. They regulate the power delivery to each motor, ensuring precise control during flight. Powering it all is the battery. Most drones use rechargeable lithium polymer batteries or LiPo or lithium ion batteries because they are light in weight and provide high energy density. The power of the battery is then distributed to all the components through a power distribution board or wiring harness. Battery capacity determines how long your drone can stay in the air. Remember to always balance performance and flight time. Sensors are what make drones intelligent. A GPS module allows for precise navigation, while an IMU helps in measuring the drone's orientation and acceleration. Some drones also use barometers for altitude measurement and proximity sensors to avoid obstacles. The more sensors a drone has, the more capabilities it unlocks. For example, advanced drones can even perform autonomous missions or follow moving objects. To control your drone, you will need a remote controller. It communicates with the drone via radio signals, often at frequencies like 2.4 GHz or 5.8 GHz. Many modern systems also let you monitor live telemetry data such as battery status, altitude, speed through a smartphone app or a desktop application. This connection ensures you are always in control, whether you are piloting manually or programming a automated flight. Finally, many drones are equipped with cameras or other payloads. Cameras are often mounted on gimbals to capture smooth, stabilized footage. For industry or research purpose, drones can carry payloads like thermal cameras, deliver packages, or even LiDAR scanners. Your choice of payload depends entirely on what you want your drone to do: photography, mapping, inspection, or many others. And there you have it, the basic components of a drone. Understanding these parts is the first step towards mastering drone technology. Whether you are flying for fun or diving into serious drone projects, if you found this video helpful, don't forget to like, subscribe, and hit that notification bell. Do you have questions or suggestions? Drop them in a comment. Happy flying!